Okay, today we'll see about table. First, we'll see about data files. This will be the last. Today we'll see about data files, and this will be the last part of our physical components. Data files. So basically, whatever the data which is present in the database is stored in the data files. So we already know the database is nothing but a collection of related data which is centralized stored in one location. So in the same way, whenever we are storing the data into the database, there are two types of data which we store. One is permanent data and the other one is temporary data. So data in the database can be of two types. One is permanent and the second one is temporary. So these are the two types of data you try to store it into the database. So permanent data is nothing but the data which will be there forever until you delete it manually or until you update it manually. The temporary data, it depends upon how you store it. It may be a transaction specific information or it may be a session specific information. So for example, if you're creating a temporary table, the data which is present in the temporary table will be stored in, it's a temporary data. It's only specific to a session or it's only specific to a transaction. You already know that. So typically you can store two types of data into the database. One is permanent and the other one is temporary. So to hold this kind of data, data files are of two types. One is permanent data file. I'll just give it as DF, and the second one is temporary files. So these are the two types of files which are present in the database and which will hold either permanent data or temporary data. So the files which are used to store the temporary data is nothing but temp files, and the files which are used to store permanent data is nothing but permanent data files. And data files are the physical files which exist on the disk. So like the files, like parameter file, control file and redo log file, even the data files will exist on the physical locations. And you will have two types of data files, permanent and temporary data files. Now, the permanent data file itself is divided into, first we will do one thing. First we'll see what, what actually a data file consists of. So basically a data file consists of four parts. So take for example, this is a data file and the data file name is example.dbf. Usually the data files are stored with extension .dbf. So think for example, this is a data file with the name example.dbf. So this will be the extension, usually .dbf, and it stands for database files. Now this data file will actually consist of four parts. The first part of the data file is called as data file header. The first part or the first component is called as header. And then you have the free space which is not used yet. So this space is not used yet by the users. So nothing is stored yet into this space. And the third component is used space. So this is the actual space which is occupied by the data, by the permanent data. So this is used space. And the fourth component is also free space as a result of deleting the data. So this was used once, but after deleting the data, the free space was again created in the data file. So free space as a result of deleting the data. So these are the four components. First we'll see what the header contains. So the file header contains the metadata information. File header contains metadata information. That means it will contain the information about what actually is present in the what is actually present in the data files. So the header part will actually are able to hear me?
Yeah, man.
Okay. Yeah. Okay. The header part contains the metadata information. Metadata is nothing but it will contain the information about what is actually present in the data file. For example, the example.dbf, the file size of this example.dbf is of 30 GB. 30 GB is the file size of example.dbf, for example. In that case, first the header part will contain what is the size of this file. So the header part will contain the size. So it will have the 30 GB. Not only that, it will contain the information about the checkpoint change number. We already know CKPT process will update all the data files with its latest checkpoint change number. So where does it updates? So it updates in the header part of the data file. So if you have 5 data files, we'll have 5 headers in the data files, and CKPT will update all those data file headers. So the data file header will have the size as well as the checkpoint change number. I'm just writing it in shortcut, CKPT underscore change number. So this is the information which is actually present in the header part. So usually in the header part, you will have the checkpoint change number as well as the data file size. It also will have the different kind of information like what kind of files are stored in the database and what kind of table space, all that you'll know it in the future. But for now, just what you have to know is like the header part contains the size as well as the checkpoint change number. And the used space means this may be occupied either by tables or by indexes, or maybe some other segments. Usually segments are the objects in the database which actually consume the space. So usually the used space will be used by the segments. So whenever you insert the data into the database or whenever you insert the data into a table, it actually stored into the data file, and that will be in the use space part of the data file. So this is how a data file looks like, the internal part. It will have the header, use space, free space, which was not used yet, and the free space as a result of deleting the data. Now, in order to store permanent data information, okay, so this permanent data files, the permanent data in the database can be either permanent or temporary. The permanent data is divided into first system data, the second type of data, part of the permanent data will be sysocs data, the third is undo data, and the fourth is user data. This is user data. So these are the four types of data which you can store into the database as part of permanent data. So permanent data itself has four types of data. One is system data, the second is sysaux data, third is undo, and the fourth is user data. So usually these three types of data will be inserted into the database as a result of Oracle database functionality. And this is the actual data which you'll try to insert into the tables. So whatever the users are creating, like if the users are creating tables or if they're inserting the information into the database, they'll usually store it into the users data part. This system data will actually contains metadata information. For example, if you want to know the information about reader log files, yesterday we saw, we'll check it in the vlog file or vlog. If you want to know the information about the tables, we'll check it in the user underscore tables. In a similar way, if you want to know the information about segments, you'll check it in user underscore segments. Indexes, user underscore indexes. If you want to know the columns on which the indexes are created, user underscore in underscore columns will give you the information about the columns. So all that kind of tables are actually stored in system data. It contains all the metadata information. So all the metadata information is present in system data. And the sysaux data, if you remember, I told you MN is a process which will try to gather the statistics of the database, like what is the CPU usage, how many sessions are running, and what is the load on the database. All those things will be collected by the M1 process. So MN. So all that kind of information which is generated by the MN process will be stored in the sysaux data file. So we don't have the sysaux data till 10G. We don't have the sysaux data. Starting from 10G, we have the sysaux data. Before 10G, to the prior versions of 10G database like 8 and 9.9, even the sysaux data was clubbed with system data. So system data, apart from the metadata information, it also used to store the statistics information. But starting from 10G, we have the sysaux data where you will store the statistics of the database. And then the third type of data is undo data. This undo data is used to provide the read consistency. For example, if a user so this is the database and SGA user. So if a user is trying to update the information in EMP table, he want to update EMP set location equal to Texas where location equal to New York. So set location equal to New York where location equal to Texas. Now he is updating, for example, he is updating 1000 records, and that updated information, which is 30 buffers, are present in the database buffer cache. The user has not committed yet. Now the second user comes in and tries to query EMP table. He want to do select star from EMP. Now what data should this user get? If the user B comes in and queries the EMP table, whether he has to get the information with the employees who are located in Texas or whether he should get the employees who are located in New York. Any guess?
Yeah.
New York?
Yeah.
Why? Because this user hasn't committed yet.
No, sorry. I mean Texas.
access. So how does this user will get the information about that access? Because in the database buffer cache, what you have is the updated blocks. So you'll
Yeah.
have the information about, I mean, like the employee information is updated with the Texas records, correct or not? Now, whenever the buffers related to the uncommitted information is present in the database buffer cache, server process will not try to retrieve that content and give it back to the user. It it will go into the undo table space or undo data which is present in the database. So undo data is present in the database which is used to store the previous values before getting updated. So whenever server process initially takes the records, take the employee records from data files to the database buffer cache, it will also store the same records into undo data. Okay. So whenever the user B comes in and tries to query the EMP table, instead of getting the blocks from buffer cache, it will pull the information from undo table space and it will give it back to the user. So this is how undo data will be useful to provide a read consistency. Read consistency means he has to get the consistent information. Is it clear?
Yeah.
So yeah, so the consistent data is stored in the undo data. So basically undo data is nothing but the data which is used to give or to provide read consistency. Okay. No. And the temp, I mean like the temp data will be only one. It has only one, which is temp. Permanent we have system, sysocs, undo and user data. Now the system data, before coming to this, so these are the physical components which we already saw. One is system. Let me draw a line. System, sysocs, undo and user data. So these are the four types of permanent data which is present in the database. Now these are the physical components. How will Oracle group these into the logical components? So let me start from the blocks. So whenever you create table, what will happen? Will a segment be created or not? If I create a table, will a segment be created for a table or not?
Yeah.
Are you sure?
Uh, but not sure because I think
I showed you while I was creating the tables.
segment.
Segment will not be created by default. Whenever you create a table, the segment will not be created. That means extents will not be allocated for the table. Whenever you try to insert a row, then a segment will be created because extent needs to be allocated for the table. Okay. Select segment underscore name from user underscore segments. So these are the segments which are present in Scott user. Okay. Now let me create a table. Create table dept emp underscore demo name varchar2 of 10. Okay, table is created. Let us go ahead and check whether a segment is created for emp underscore dem or not. No, right? So whenever you create a table, automatically a segment will not be created. Whenever you are trying to insert some data into the table, then it will allocate extents to the table, and as a result a segment will be created.
I think we didn't cover this. Maybe I'm not sure. Like,
No, I covered it. I covered it while I was creating the tables and I showed it to you.
oh, okay.
Because I covered user underscore segments, I remember. So I also covered that one.
Oh, okay.
If you remember, like I also showed you user underscore extents and I showed you how the blocks will be allocated.
Yeah, let me go through the video once again. Then, yeah.
Yeah. So first, whenever you are trying to insert okay, right now there is nothing for this segment, which is emp underscore dmp table. There is no segment. Next, let me check it in the extents also. Maybe I haven't covered it, so I'm just covering it now. Select segment underscore name, extent underscore id, blocks from user underscore extents. I'm just worried about emp underscore dmp table, so I'll just go for that, where segment underscore name equal to emp underscore dmp. So if you see here, segment is not created yet. So this query will return 0 rows because there is no segment with the name emp underscore dmp. Okay, so that means nothing is allocated here. Usually, whenever you are trying to insert data into the table, the space will be allocated in terms of extents. I'll tell you what is an extent, but just remember, whenever you are trying to insert data into the table, it will be one second. So whenever you're trying to insert the data, first an extents will be allocated into for the table and a segment will be created. So while you create a table, by default just an object will be created, but not a segment. Segment will be created if it is trying to consume the space. Now if I try to insert a row into the table, insert into emp underscore dmp values Mohan. Now as I inserted data, as I inserted one row into the table, it will consume some space, and the string which I inserted will consume 1, 2, 3, 4, 5 bytes, correct? Because there are 5 characters and each character will occupy 1 byte. So the size of the table should be 5 bytes. The actually occupied size of the table should be 5 bytes. Am I correct or not?
Yes. Yeah.
Now if I do select segment underscore name, extent underscore id, comma, blocks bytes by 1024 from oh okay. So now if you see here, the moment I inserted a row into the table, a segment was created, and as a result there is one row associated with that segment. Now if you see here, there is one extent allocated for emp underscore dmp, and that extent is of size 8 blocks. And we already showed you, like, I created the database with 8 KB. Show parameter, do you remember that?
Yeah. db underscore cache equals this.
db underscore block underscore size. This will give us the block size of the database, which is 8 KB. And if you see here, 8 blocks are allocated for this segment. That means it is occupying 84 KB, 64 KB. Each block is of 8 KB and 8 blocks are allocated. That means the total size will be 64 kilobytes. Correct or not?
Yeah.
Yeah. So even though I inserted 5 bytes of information, still 64 kilobytes was allocated for this emp underscore dmp table by default. That is because whenever you are trying to allocate space to the table, it will be allocated in terms of extents. Because whenever you are trying to insert the data, for example, right now you insert one row. Again, if you want to insert 10 more rows, again Oracle needs to allocate the 5 bytes of information. Instead of allocating 64 kilobytes, if it just allocated 5 bytes for that row, for the table, then for each and every insert statement, it needs to calculate how much of space needs to be allocated, and it needs to allocate that much of space. So it will take a lot of time, and as a result the insert statement will also be slower. So that is the reason why whenever a segment requires some space, the space will be allocated in terms of extents.
Okay.
So these are the physical files. Now logically what we will have will be first Oracle block size. Oracle block. This is the smallest segment or the smallest component of the logical structure, Oracle block. So depending upon the Oracle block size, for example, if the Oracle block size is of 8 KB, that means, and your operating system, for example, if you're formatting a pen drive, I guess I told you this example. If I'm formatting a pen drive of 2 GB, first I'll select the file system type. After that you'll have the option of the block size. In a similar way, whenever you're creating or whenever you're installing the operating system, even the operating system will have some block size. That block size, for example, that block size is 512 bytes. This will be the physical block size, but not the Oracle block, because from the operating system perspective, a block is 512 bytes. If you are creating an ext3 file system, and that file system has a block size of 512 bytes, and that ext3 file system is, for example, /oracle, okay, and this /oracle size is 1 GB. So when you are creating a mount point with /oracle as 1 GB, this 1 GB will be allocated in terms of 512 bytes. The total number of blocks will be 1 GB by 512 bytes. So this will be 1 into 1024 into 1024 into 1024 by 512 bytes. So that will be equal to number of blocks. So this /oracle will be having that many Oracle operating system blocks. Okay. Now whenever a block is allocated for the Oracle database, it will be allocated in terms of 8 KB. That means How many blocks of operating system needs to be allocated for Oracle block? 16. 16 512 bytes will correspond to, sorry, 160 actually. If it is 512 bytes, then it needs to allocate probably 160, I guess. We need to calculate. Think for this is 160 byte. 160 blocks needs to be allocated for having 8 KB of block size. So this is the physical thing. Operating system block size is a physical component, but not the Oracle block, because Oracle block will just think of Oracle block once we are in the database. Once we come out of SQL Plus, or once we come out of database, once we get disconnected from the database, the block size will be operating system block size only. So that is the reason why even the Oracle block is a logical component, and this is the smallest component. Everything, the smallest logical component will be 8 KB. So whenever you are trying to insert some data, it will be inserted into a block. For if I inserted Mohan, I inserted one row Mohan. Even though 8 blocks are allocated for EMP underscore DEMP, only one block was used to store Mohan because it just requires 5 bytes. Now this is the basic unit of Oracle database, Oracle block. Then group of blocks will form a extent. For example, if this is Oracle block which is of 8 KB, now one more 8 KB, one more 8 KB, and one more 8 KB. So there are 4 Oracle database blocks which are available. Think this as an example, and there are 4 Oracle database blocks which are available. Whenever a table is trying to allocate whenever Oracle is trying to allocate an extent for the table, and it saw 4 blocks are present, or for example, say there are 1 2 3 4 5 6 7. I'll do one thing. I'll just okay. Now this is a table. Initially it doesn't consume, it is not consuming any space. Now when I inserted one row into this table, it requires 5 bytes of information. So whenever it is trying to consume the space, whenever Oracle is trying to allocate space for this table, it will be allocated in terms of extents. That's what I said. So Oracle block is nothing but group of operating system blocks. Now for example, I have 10 blocks available which can be in a data file. Okay, so data file is nothing but it will contains blocks. Now I have 30 GB of 3 GB of data file, for example, and this data file name is example.dbf. Now whenever I'm creating a data file which is of 3 GB, this 3 GB of space will be allocated in terms of 8 KB blocks. Okay, and now in this 3 GB of data file, I have 10 blocks which are free. 1 2 3 4 5 6 7 8 9 10. So think there are 10 blocks which are free. In this 3 GB of data file, there are only 10 blocks which are of free space. Now it needs to allocate an extent for this table, and that extent size will be, if you see here, by default it allocated 8 blocks, correct? So the extent size is 64 KB. Think it needs to allocate 64 KB of extent. So what it does is it actually allocate the blocks. Out of these 10 blocks, it will actually allocate 10 blocks, 8 blocks, because it needs to allocate 64 KB. So out of these 10 blocks, it needs to allocate 8 blocks to form an extents. So whenever it is trying to allocate blocks for an extent, it will only take the contiguous blocks into consideration. For example, out of these 10 blocks, only 8 blocks are in contiguous locations. That means the address of this block is 100. The address of the next block is 101. So they are contiguous. That's side by side. So those 8 blocks will be allocated for that extent. So extent is nothing but group of blocks extent. It is nothing but it is a group of contiguous blocks. And whenever Oracle needs to allocate space for the segment, it will be allocated in terms of extent. Is it clear? So think whenever Oracle is trying to allocate an extent, it will only allocate contiguous blocks. If the blocks are not contiguous, it will error out saying there is no sufficient space. For example, in this data file, there are 10 blocks which are free, and it has to, if it, even though there are 10 blocks and if they are not contiguous, in that case it will error out saying that there is no sufficient space available in the data file. I cannot allocate 64 KB of extent. Okay, whenever it tries to allocate an extent, it will always allocate the extent as a contiguous blocks. And a questions in iPod,
No.
okay?
Yeah, okay.
Okay. So nothing, a block, Oracle block is a basic unit for input-output operations, and group of contiguous blocks is nothing but an extent. After that, we have a segment. Segment is nothing but group of extents which belongs to same object. Give me a second, let me get my charger. So group of extents which belong to the same object is called as a segment. Oracle block is the basic unit of storage for Oracle database, and it is group of operating system blocks. So whenever Oracle tries to write data to the data data files, so which process will take care of writing the data to the data files? DBWR. So whenever DBWR is trying to write dirty buffers from buffer cache to the data files, how it will write the blocks? What will be the buffer size in the database buffer cache?
Buffer size.
Yeah.
Minimum we can give, right? For that, like, what is the minimum space we can give?
I'm
DB
asking about the buffer size. Database buffer cache, that is you're talking about database buffer cache. What I'm asking is the buffer size. So database buffer cache inside will have the in terms of buffers, right? Buffers will be allocated. Yeah. So what will be the
8
size of
KB.
that buffer?
8 KB. 8 KB.
Why it is 8 KB? It is equal to Oracle data block size.
Okay. Yeah.
So you should not straight away say it's 8 KB. You should say it is equal to the Oracle database block size.
Okay.
So whenever our data DBWR writes dirty buffers from buffer cache to data files, so what buffer it will write? What size of buffer? It's 8 KB buffer. So every transaction will be in terms of blocks only. So it will write in terms of 8 KB.
Okay.
Now thinking that, for example, if you have operating system block size as 512 bytes, okay? Operating system block size is 512 bytes. Now, can you tell me, can I have an Oracle block with seven 512 plus 256, 768 bytes. Yeah. Can I have an Oracle database block size with 768 bytes? I can create a block size. I can create a database with a block size, whatever may be the block size. Like I can create it with 1 KB, I can create it with 8 KB, I can create it with 16 KB, or I can create it with 32 KB. Just I'm asking you whether I can create an Oracle database with a block size of 768 bytes. If so, what will happen? So as I said, whenever Oracle is trying to perform input output operations, it will be performed in terms of 512 bytes.
Yeah.
Correct? Sorry, in terms of 8 KB. Correct or not?
Yes.
Okay. Now, I'm like in terms of database block size. Just think the database block size. Okay. Now, if I create a database with a block size of 768 bytes, what will happen? As a result, whenever Oracle is trying to perform input or output operations, it will try to perform in terms of 768 bytes. Correct? Now, what is the operating system block size? 512 bytes. So if it is writing 768 bytes, it needs to use 1024. 2 blocks of operating system.
Yes.
That means rest of 256 bytes are getting wasted. 244 bytes.
Yeah.
Correct? Otherwise, if I have the block size as 1 KB, and Oracle will always perform input-output operations in terms of 1 KB. As a result, it will use 2 blocks of operating system and it efficiently writes. There is no space getting wasted. Correct or not?
Yes.
So to save input-output operations or to perform input-output operations in a better way, whenever we are creating an Oracle database, whenever we are determining an Oracle database block size, it should always be multiples of operating system block size.
Okay.
Clear?
Yeah.
So these are the logical components. Oracle block, extent, and group of extents is nothing but an extent segment. Okay.
Okay. Okay.
Now these data files. Now we have system data file, sysocs. We have system data, and we also have sysocs. User and undo. And we saw data file contains data file header. After that, it contains the free space, used space, and free space which was never used. For example, these are the components. Now, the data file of 3 GB will be divided in terms of blocks. But this is a physical component. Oracle needs to provide a logical way in order to efficiently manage these data files because this is a physical component. So what Oracle did is it created a logical component called as a table space. And using this table space, it will group the data depending upon what type of data is stored in the data file. So if the data stored in the data file is of system related, if the metadata is stored in a data file, then it grouped that file into a system table space. If it is storing any statistical information, sysocs, so it is nothing but sysocs table space. Undo is stored in undo table space. User data, it depends. You can create as many table spaces you want in order to store the user data. So basically a table space is a logical entity which can have one or more data files. So if you see here, the system table space has one data file which is system.dbf. Now we can also add one more data file to this table space. So basically a table space is nothing but one or more data files That's it. It's a logical entity which contains one or more data files. So the physical component, the physical structure of the Oracle is just a data file. But the logical components are block, extent, segment, and table space. So these segments are stored inside the table space. So this is the logical architecture, the logical components, and this is a physical component, data file. Now, whenever you are trying to create a database, the minimum number of required table spaces are two. One is system and second one is sysocs. These are the two mandatory table spaces which are required whenever you are trying to create database. But Oracle recommends to have one more table space for undo and another table space for temp. So we already know undo is used to store read consistent information and temp is used to store temporary information. So basically whenever you are creating a database, Oracle recommends to create these four table spaces. And system is used to store system data, which is metadata information. So all the data dictionary views like user underscore tables, user underscore segments, user underscore extents, video log file, all those are data dictionary views. So those data dictionary views will consume space in system table space. System table space contains metadata information, and sysocs, it contains statistical information. Undo is used to store consistent information for providing read consistency, and temp is used to store temporary information. So if you want to get information about table spaces, you will query user underscore table spaces. And from now onwards, we will not concentrate with user underscore. Whatever views which I told till now, like user underscore tables, user underscore extents, user underscore segments, user underscore in underscore column, user underscore indexes, all these will also have an associated DBA views. So if you have user underscore tables, you'll have a DBA underscore tables. If you have user underscore segments, you'll also have DBA underscore segments view. So from now onwards, we'll only query DBA underscore views. Now, if I want to get information about table spaces, it is present in a data dictionary view called as DBA underscore table spaces. This will give you the information about table spaces which are present in the database. So select table space underscore name from DB underscore table spaces. So if you see here, I have system, sysocs, undo, and temp. These are the four Oracle recommended table spaces which we want. System, sysocs, undo, and temp. Now the rest of the two table spaces are created as part of creating Scott schema, and rest of the by default whenever you are creating a database with DBCA, and if you select sample schemas, if you remember when we are trying to create the database, we check the sample schema option. So whenever it is trying to create sample schemas, it will also create two table spaces, users and example. But Oracle recommends to have these four table spaces: system, sysocs, undo, and temp. Whenever you're creating a database, these are the four table spaces which are required. After that, if this database is being used by the users, then depending upon the application type, you'll create a new table space. For example, if the application is for some airlines company, in that case, if you want to store the information about flights from, I mean, like the flight details, when it is departing, when it is taking off, all those details. In that case, if that is related to an I mean like flights information, then you'll create a table space with the name some which makes some sense, like flight or something like that, and then you'll store the tables inside that table space. So depending upon the type of application, you can create a new table space apart from four Oracle recommended table spaces. Is it clear?
Yeah, I mean, just one question, small question, like, I mean, undo table space is not mandatory.
I mean like the mandatory are system and sysocs.
Okay. Ante, I mean, ante, we can create the database without undo table space. Is there any way, like, I mean, I think last time in interview, you asked me, like, one question regarding the undo table space. Is it,
Yeah. Yes, we can create a database without undo table space.
oh, okay. Yeah, last
It
time,
will
I
use
mean, my
system
mock
table
interview,
space.
he asked me, like,
It will use system table space.
yeah,
So that's what I'm saying. The mandatory table spaces are system and sysocs, but Oracle recommends to have temp and undo also.
okay. Yeah, it's clear now.
And information about data files is present in db underscore data underscore files. This will give you the information about what are the files, what is the file name, and what is the size of the file which is present in the table space. So select table space underscore name, file underscore name from db underscore data underscore files. So if you see here, users table space has one data file, users01.dbf. Undo, undo tbs1. sysocs, sysocs, system, system, example and example01.dbf. So these are the files which are present in the table space. So to get information about table spaces, we will query db underscore table spaces. If you want to get information about the physical files, you will query db underscore data underscore files. If you see here, one of the table space is missing. Can I know what is that? Yeah,
Temp.
temp. So if you want to get information about temp files, it is present in db underscore temp underscore files. As I already told you, we have permanent files and temporary files. So permanent file information will be present in data files. Temporary file information will be present in dba temp files. See, I have temp table space and this is my temp file.
Hmm.
Now, if I want to know how much of size is allocated for this table space, because we need to worry about how much of size is allocated for the table space itself, but not for the data files. Because logically, whenever you're trying to create a table, it will be created in a table space, but not in a specific data file. Logically, I mean like whenever you're creating a table, you'll specify the table space in which you want to create it.
Okay.
So it is stored in the table space. So every time if you're talking about space, you need to talk about the space, how much it is available at the table space level, but not at the data file level. Now, if I want to know how much of space is available in a table space, total space, how much of space is allocated for each table space, I will again query I'll do. So in DB data files, there is a column called as bytes, which will give you the size. So here, users table space, the total size allocated is 5 MB, undo TBS 60 MB, sysocs 510 MB, system 680 MB, and example 100 MB. These are you can check how much of space is allocated. Now, out of this space, if you want to know how much of free space is available, this is the total size allocated for the table space. Now, if you want to know the free space, how much of free space is left in each of the table space, then you have to query free underscore space, db underscore free underscore space. So try to memorize all these data dictionaries which are very important. dba free space will give you the information about how much of free space is left in each of the table spaces. So if you see here, the system is repeated twice. Undo tbs is also repeated thrice and example is also repeated thrice. So what should I do in order to get just one table space and the bytes?
Distinct.
Distinct?
Select distinct table space name.
No, that will not give me, because if you see here, distinct system, if I do select a distinct table space name and bytes, This is one unique row.
Oh, okay, okay,
This is
yeah.
also one unique row.
Okay, okay.
So what should I do?
Mm, I mean, we can add these two, or like we can't.
Yeah,
We
but
are
I
not.
want to do that with a query.
Yeah. Like select a table space name,
Mm-hmm.
maybe add or some add.
Add.
Yeah, I mean some sum of bytes. Like
Mm-hmm.
I mean, yeah.
Okay, that's it.
Yeah, sum of bytes.
Ashish?
Yeah. Maybe that will do.
No. Whenever we are using what type of function is sum?
Oh, order by table space name.
Order by what order by will do? It will sort the columns based upon the
Oh,
values.
yes, yes.
But why I have to use order by?
It will give the only one value, right? Like
How come?
system.
No, if I do order by, it will just try to sort the data. So first example will be coming in first, then system sysox system users and undo TBS. But that is not I want, right? System will be repeated twice, sysox will be repeated once, undo will be thrice, example will be thrice. But it will
Uh,
just sort the order.
Group by? Yeah, group by. Group by table space name.
Simple. Whenever you are using any group function with a column name, you need to
Yeah,
specify this column name in a group by clause.
yeah.
Okay. Now I got the total free space available. So out of 510 MB, which is allocated for sysox, the total free space left is 24 MB. Am I correct?
Yeah.
Okay. Now I want to join dba free space and dba underscore data underscore files such that I want to display the output in such a way table space, the total size allocated, and the
Mhm.
free space available. Can you give me the query which can perform that?
Yeah. DBA. Yes. Can you move this block? Like,
Let me describe it.
yeah.
Okay, 1 second.
Let me try in my system. Yeah.
No, just check it here. The column and what should be done.
Select table space name,
Okay.
comma, free space, and
Okay. First see here. Uh, if you see here, db underscore data files has table space underscore name column, and db underscore data free underscore space also have table space name column. Correct?
table space.
So we need to
Yeah.
join the two tables with table space underscore name column. After
Yeah.
that, what are the columns I have to refer? I have to get table space name. After that, I have to get first. I have to get the table space name column. But table space name column is present in both the tables. Both
Okay.
the tables. So what I have to do? I have to give an alias name.
Okay.
So I'll just give d dot
Data file. Yeah,
table
yeah.
space underscore name. After that, I have to get the total size allocated for the table space. That I will get it from DBA data files, correct?
Yes.
So what I have to do? D dot
D dot.
bytes, comma.
Yeah. Like you can
Okay,
do.
1 second. Let me do sum up. Sum of d dot bytes. After that, I have to get the bytes from.
Three tables.
Okay, so I'll give it as f dot,
Bytes.
yeah,
Sum of.
sum of f dot bytes by 1024 by 1024.
From tables dot d comma. Yeah. Space name equal to.
That's it, or do I have to do anything else?
Group by table space name.
Yeah. So these are will get the information, the
Yeah.
total size and the free space. Okay.
Okay.
Now there are two types of, in Oracle database we can create two types of table spaces. One is permanent table space, the second is temporary table space. Permanent table space and the second type is temporary table space. Okay. The permanent table space is of two types again, big file table space and small file table space. So first we'll see what is the difference between a big file table space and a small file table space. By default, whenever you have a database with 8 KB block size, okay, whenever you have a database with 8 KB block size, the maximum size for a data file can be 32 GB. This is the maximum size a data file can grow, till 32 GB. Now if you want additional space for this table space, for example I'm creating a table space called as flex. This is my table space name, okay, and this is used to store users information. Now I created this flex table space, added one data file called as flex1.dbf. Okay, this flex1.dbf size is 32 GB. User created 200 objects and as a result the total 32 GB is used. So what is the option for me in order to increase this table space? Because users will be trying to insert some data into the table space again. They'll be trying to insert the data into tables. As a result, I require some more space in this flex table space. Am I correct or not? So now, how can we add some more additional space to this table space? Any guess? The maximum size which we can have is 32 GB. That is the limit. Now,
Okay.
but I need some additional space into this flex table space. So is there any other option? Just think of table space definition. As I said, it's a group of one or more data files.
Data file size increase.
Data file size 32 GB అండి, ఇంతకంటే max increase
Okay.
చేయలేం. Table space definition is nothing but it contains one or more data files.
Data files.
Okay. Now I cannot increase the size of this data file. So the other
Okay.
option, what is the other option available? I
You
can
can
add
add
one
more.
more data file.
Yeah.
So if you're having a small file table space, the maximum size of a data file you can create on 8 KB block size is 32 GB, and you will have multiple data files in order to create a bigger size of table space. Coming
Okay.
to a big file table space, we will only have one data file. If the type
Mm-hmm.
of table space is a big file table space, you'll only have one data file, and the maximum size of the file you can create is 128 terabytes. Using big file table space, the maximum size of a data file you can create is 128 terabytes. Okay, so when we have to use a big file table space or when we have to use a small file table space? Any guess?
Uh, if you know, like size of the table is like.
Okay, let me give an example. Okay, I'm trying to create a table which is of 3 terabytes. This the size of my table is 3 terabytes.
Okay.
So which of the table space you'll suggest? Big file table space or a small file table space?
Big file table space.
Why?
Oh, 3 terabyte, 128 terabyte. Okay.
Can I know the reason why you want to prefer to big file table space?
Because we have to add more data files. I mean,
Okay, but that should not be the answer. It will not depend upon the table size. It will depend upon how much of size you have on each of the mount point. For example, I have
mhm.
the mount point slash database, okay,
Okay.
and the size of this mount point is 100 GB.
Okay.
By creating a big file table space on this slash database, will I get any benefits?
No.
Because I cannot grow more than 100 GB.
More than 100. Yeah.
So it depends upon the mount point. If you don't have sufficient mount point space to create a
Mhm.
3 terabyte file, then it's better to go for a small file table space such that you can use additional mount points to add some more data files into different mount points.
Okay.
So it will depend upon the mount point. If you have a bigger
Okay.
mount point, you can go for a big file table space. If you have a smaller mount point, you can go for a small file table space. There are
Okay.
also there are also some more disadvantage with big file table space actually. For example, if the file is getting corrupt, if the file got corrupted, here the
Okay.
total 128 terabyte will be corrupted. In a small file, part of the table space will be corrupted, not the entire.
Okay.
Okay.
Okay. సపోజ్ మౌంట్ పాయింట్ వచ్చేసి మనకి ఐ మీన్ 5 టెరాబైట్స్ ఉందండి.
Mm-hmm.
ఐ మీన్ లైక్ మోర్ దాన్ 5 టెరాబైట్ లైక్ మౌంట్ పాయింట్ వచ్చేసి 100 టెరా ఐ మీన్ 10 టెరాబైట్ ఉంది. మనం 3 టెరాబైట్ టేబుల్ స్పేస్ క్రియేట్ చేయాలనుకోండి. అప్పుడు మనం ఇది స్మార్ట్ టేబుల్ స్పేస్కి వెళ్తాం లేకపోతే ఐ మీన్ బిగ్ టేబుల్ స్పేస్కి వెళ్తాం. అంటే
Yeah.
మన అడ్వాంటేజ్ డిసడ్వాంటేజెస్ ఉంటుంది అట్లా.
యా అంటే ఆ కేసులో అంటే యాక్చువల్గా 3 టెరాబైట్స్ టేబుల్ ఉంటే కనుక దాన్ని ఒకే టేబుల్ ఉంచాం, దాన్ని పార్టిషన్ టేబుల్గా క్రియేట్ చేస్తాం.
ఓకే. ఓకే.
అది అక్రాస్ డిఫరెంట్ టేబుల్ స్పేసెస్లో పెడతాం.
ఓకే.
యా, సో మోస్ట్లీ స్మాల్ ఫైల్ టేబుల్ స్పేస్ ప్రిఫర్ చేస్తారు బిగ్ ఫైల్ టేబుల్ స్పేస్.
అందుకే ఎందుకంటే ఇక్కడ మళ్ళీ మనం 3 టెరాబైట్ 120 టెరాబైట్ అంటే ఐ మీన్
అంటే మనం 3 టెరాబైట్స్ కావాలన్నప్పుడు త్రీ ఇస్తాం కదా, 128 ఇవ్వం.
మాక్సిమం అది సపోజ్ 10 టెరాబైట్ అనుకోండి.
Hmm.
ఎక్కువ మనకి 3 టెరాబైట్ టేబుల్ సైజ్ ఉంది అనుకోండి.
Mhm.
అప్పుడు అంటే అర్థం కాలేదు క్వశ్చన్.
అంటే ఓనర్స్ అసలు ఎప్పుడైనా వాడతారా ఇట్లా బిగ్ టేబుల్ స్పేస్ ఇంత పెద్దది?
యా యా ఉంటుంది.
అదే మళ్ళీ పార్టీషన్ చేస్తాను కదా, సో అదే వాడతారా లేదా అని.
లేదు వాడతాం. ఇప్పుడు నేను చేసే దగ్గర 100 TB డేటాబేస్, 100 టెరాబైట్స్, జస్ట్ 2 టేబుల్ స్పేసెస్ ఉంటాయి, 5 TB 50 TB 50 TBతో.
ఓకే
ఇట్ డిపెండ్స్ అంటే కంపెనీ ఎట్లా ప్రిఫర్ చేస్తా అన్నది దాని మీద డిపెండ్ అయి ఉంటుంది.
ఓకే ఓకే
బట్ ఐ మీన్ లైక్ ప్రిఫర్ అయితే నాకైతే స్మాల్ ఫైల్ టేబుల్ స్పేస్ ప్రిఫర్.
ఓకే
బట్ కాకపోతే ఏంటంటే బిగ్ ఫైల్ టేబుల్ స్పేస్ తోని అడ్వాంటేజెస్ ఉన్నాయి. ఊరికే ఇప్పుడు 32 GB ఫిల్ అయితే నేను ఇంకో డేటా ఫైల్ యాడ్ చేయాలి. ఇక్కడ నేను అది చెప్పాల్సిన అవసరం లేదు. మినిమం సైజ్ 3 TB, మాక్సిమం సైజ్ 120 TB నేను ఇచ్చేసాను అనుకోండి, ఆటోమేటిక్ గా ఎక్స్టెండ్ అవుతూ వెళ్ళిపోతుంటుంది అది ఇంకా.
ఓకే
ఓకే, I'll wind up the class and I'll continue on Tuesday.
ఓకే
Yeah. Okay then, bye.
మోహన్ అవి వీడియోస్ అప్లోడ్ చేయరు.
నేను చేస్తాను.
ఓకే
Yeah. Bye.
Bye, Mohan.
Bye, Ashish.
Bye, Shiva.
బాయ్.